One of the biggest myths about machine learning is that it actually understands the world. It doesn't. Machine learning doesn't reason, it doesn't think, and it definitely doesn't grasp meaning. At its very core, machine learning is all about one thing: prediction. Think about it like this. You give a machine learning model some input data, and it predicts an output. That's really it. It might predict what video you'll click on next, whether an email is spam, the future price of a house, or if a credit card transaction is fraudulent. But in every single one of these cases, the fundamental task is the same: making a prediction based on patterns it found in the data it was trained on. Now, why does this distinction matter so much? It's because a huge number of failures in machine learning systems happen when we expect these models to do more than they are capable of. A model doesn't make a decision on its own. It doesn't understand context the way a human does. All it does is spit out a probability or a score. For example, a recommendation system on a streaming service doesn't decide what you want to watch. It simply predicts the likelihood that you will click on or watch a specific movie or show. The actual decision what to display on your home screen, how to rank the results, or what action to take next is made by the larger system built around the model, not by the model itself. This is exactly why framing the problem correctly is one of the most critical steps in the entire machine learning process. Before you even think about choosing a model or collecting data, you have to ask yourself, what precisely are we trying to predict? If you can't phrase your problem as a prediction task, then machine learning is probably the wrong tool for the job. Any task that requires strict logic, guaranteed correctness, or explicit step-by-step reasoning is often much better handled by traditional software engineering. Another major implication of these prediction-based systems is uncertainty. No prediction is ever going to be perfect. Every single model, no matter how sophisticated, will be wrong some percentage of the time. This means that any system using machine learning has to be designed from the ground up to handle mistakes gracefully. When you're building a real-world production-level system, accuracy alone just isn't enough. You have to consider how prediction errors will affect your users. You need to think about how confident the model is in its predictions and have a plan for what to do when the model is unsure. The best machine learning systems don't try to hide this uncertainty. They embrace it and account for it in their design. So, when you start thinking of machine learning as a prediction engine, it helps engineers design much better, more robust systems. It prevents us from having unrealistic expectations about what AI can do. It clarifies the specific role of the model within a larger application. And, most importantly, it draws a clear line between the act of prediction and the act of decision-making. Machine learning is an incredibly powerful tool when it is used for what it excels at: finding complex patterns in massive amounts of data and making predictions at a scale that no human ever could. But if you expect it to reason, understand, or think like a person. You're setting yourself up for fragile systems and disappointing outcomes. Ultimately, building successful machine learning products isn't about creating the smartest or most complex models. It's about building intelligent systems that use predictions in a responsible, reliable, and effective way. Thanks for watching, and if you found this helpful, don't forget to like and subscribe for more content on building real-world tech.